it seems I'm getting much worse accuracies. Okay. So at this point, I want to invite you to do this exercise. Do these two exercises, 1.2 and 1. Again, my goal is to get you used to running code. Okay. If we go slowly at this point, and everybody becomes used to running code, used to taking care of the problems, then we can move quickly together later. Okay. So please do these two exercises, exercise 1.2 and exercise 1.3. Okay. So when I come around, I should be able to see this code, and I should be able to see this code. Okay. So please go ahead, and I will exercise 1.2 and 1.3. Okay. Let me go to this side because I didn't go here before. Good. So you are getting some variability. Yes. So you want one. Everything okay?
Yeah, well, I don't know what's about. So let's get that grace. What's it about?
Oh, well, because we're trying to classify children in responsibility. Yeah, so the activity is the activity of the classification. Yeah. All right, so go ahead and do that. I'll come back. Is everything okay here? Or are we doing? Oh, this is something. Are you doing this? Okay. Yes. So did you make the table? It looks like you don't have it. Well, but where's your phone? Like, yeah, well, you need like yes. Yes. So, but you should do 1.2. This was mine, but there was like false instruction. Okay. Yeah. Here's this. Here's this. Okay. Right. Well, you can make a longer list. Longer. Yeah. You won't have. Oh no. All right. No, you did. No, I'm sorry. Correct. So you have 1.1. That's fine. You're getting. You're getting about. No, no. I'm sorry. You're fine. Want to go ahead? we're just going to be working slow. Okay, so let's go on to 1.4. Okay. So I'll do this myself quickly. Let's do a few more here. These test sizes are not really very reasonable. I'm going to use the ones that are suggested, 0.1, 0.2, 0.3, 0.4, that's fine. And then here I'll use any random seeds that I want. I'll just start with 0, 1, 2, 3, 4. Okay. And let's see what we have. All right. So two things to compare. If you look across rows, if you look across rows, you may try to see which test size is giving me the best accuracy. Okay. And you can see it's somewhat inconsistent. It does seem that you're getting better accuracies with small test size, except down here, it's not the same. So there's not a clear difference in accuracy between test size. The other thing you want to look at is variability. How much variability is there in the numbers? Okay. So if you look down the columns, how variable are there? This should be roughly the same number because you're measuring the same thing, but there's variability. Okay. So one thing to take away from this is that this table is really too small to conclude anything definite. I can't really tell which if accuracy is different for the different test sizes, and I can't really compare the variability. Okay. All I can tell is there is variability both when I change the seed and when I change the test size. So if I want to quantify this further, I will need to do a larger test. In particular, instead of 5 seeds, I want to run 1,000 seeds. Now, if I run 1,000 seeds, this is a very big table. And this is where histogram comes in. When you're doing a lot of repetitions, you want a graphical representation rather than a table representation. Okay, so what I'm going to do is exercise 1.4. Okay, so exercise 1.4 is similar. I'll get you started on this. Okay, so I'm going to copy the cell above, and then I'll paste it, I'll right click and paste below. All right, so the way you do that, as we saw, right click here, copy cell, go here, click here, right click, paste below, or just paste cell, it should be fine. Okay, and you can see that the cell is here. So now we follow the instructions. In the new cell, set random seeds equal to np.a range of 1,000. So what does this do? This creates 1,000 different trials. Then show table equals false, show histogram equals true, and then run the cell. Okay, so let me give you 2 minutes to do this. I hope this is not too difficult, and see if you can do this. And then once you do this, discuss your answer with the neighbor. Okay. The important thing is to be able to interpret your results. What do your results show? We've been talking about policy. All right, the results you get should direct what you do with your data. Okay, so go ahead and do that, please. And again, I will come around and see. So is it working? Okay. You have a problem? Oh, you're still doing 1.2. So it looks again like you're not like somehow either it was corrupted or you didn't run all. What the fuck? This is very strange. Where are the rest of your cells? So we just start here. So did you do this? You go all the way through like this? Okay, you always need to run it. I think that's the problem. Okay, everything is good so far. It looks like you're here, 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 good accuracy. Okay. I think it's okay. Let's see. All right, let's see. Now it's fine. So now you can continue. Did you do this exercise? Yeah. Okay. Okay. All right. That's fine. Good. And you're okay? Everything's working? Okay. Yeah, good. Okay. All right. No, all right. Okay. Oh, that's right. For Colab, if you're in Colab, you just go to edit. Yeah, and then should be copy cell. Copy cell. No, copy cell. Right? No, copy cell.
Copy say, look,
Yeah. Yeah. And then now go down after this exercise. And after this, now you just click on this exercise, click here, and then go to edit, and then paste. And it should have pasted below. Let's see if it did. Oh, wait a minute. It said use control Y to paste the content. So maybe it's different here. So yeah, just go down again and click between the cells. Click between the cells. No, well, you can do that. You can paste the content, but try control Y and see what happens. Nothing.
Control.
Okay. Yes. Okay, that's fine. All right. So now go back to 1.4 and follow the instructions. Yeah. Yes. 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 You have to find where it sets random seed. That's not where it sets the value. It sets the value of random seed. That's it. You have to go to the top. You see, this is where it sets the value. And you have to change this. Yes. Yeah. No, that's not what it says. Go back and see what it says. It's not quite because it didn't quite say that. It said nt.a range. No, go back. This is not what it said. Yes. Yes, that's right. Yeah, I don't want a single value. I want all of these values. Yes. Yes. No, there are not two R's, only one R. Right. But now the other thing is that don't hit granny. True. Okay. Okay. Yes. Yes. be able to run. Go ahead. Your wife, I think it's a connection. Taking time. Let's take the time. Well, let me go around, but you should see two. You could see two histograms, and you can compare and see what's going on. Yeah. You know, you may consider trying to go to the ESCO because you're going to have this problem with poor connection. Everything will be slow to execute. So you may consider doing this. But then, yeah. Okay, let's see. Okay, yes. All right, yeah. Now, this is all right. Now, if you notice, the instructions were to paste the command np.arange. Arange is not a range. Arange is the letter A followed by the word range. Okay, so it's a spelling mistake. It's ARANGE, not two R's. Yes, that's right. So you want to find it. Fraction. All right. So it's two. So I'm going to go up and run mine. Let's see. Okay, so I have it here, and I'm going instead of this, I'm going to do np.arange. Oh, sorry. So I'm going to change the random seeds to np.arange, and then 1,000 seems to take some time. So I'm going to change instead to 500. You can do 1,000. It seems to take some time to run. Okay. And I'll do these test sizes. I think I'm going to add one. I'm going to do 0.1, 0.3, 0.5. And maybe I'll do 0.7 also. That's fine. Okay. Okay. So let me go ahead and run. Okay. And we'll see what happens. It's taking time because it's doing 1,000 fits on 4 different that's why it's taking time. It's actually doing 4,000 fits. So we'll see what happens. I guess it's done. Let's see what it gave me. Oh, I forgot to change it, show histogram. So I have to redo it. Sorry. So this should be false. I don't need the table. I want the histogram. Okay. Okay. And I run again. All right, so let's see what we got. All right, so you see I have several histograms. And what you want to do, what do these histograms mean? This means the accuracy value I obtained with this test size, 0.01, for 1,000 different runs. This one gives me the accuracy, what I got for 1,000 different runs for test size 0.03. And this is 0.05 and so on. I think I go on all the way up to, there should be several of them. Let me see. I'm not sure why it's not displaying all of them. Maybe it's down. Can I show it this way? Let me see what this does. I guess that's copy. I can copy and then paste it, or I'll save it. We'll just save it and then I can open it. Okay. Save plot image here. And then I'll open it in my folder here. It should be here. Okay. It looks like there's only three. 0.1, 0.3, 0.5. All right, so let's compare the mean and the standard deviation. What are you seeing about the difference in mean? Okay. Here the mean is about 0.075. Here the mean is about 0.075. Here the mean in the middle is about 0.075. So the mean is quite consistent. The mean is not changing depending on the test size. Now, what about the variability? Look at the low value here. This goes down to 0.6. I'm getting values between 0.6 and 0.9. Okay. This is not good. This means that my result will depend a great deal on my test size. This is not good. So this shows that test size of 0.1 is not good. Test size of 0.3, what's my variability? This is 0.65 up to about 0.85. Okay. So this is much better. But in fact, this one is about 0.60 to about 0.80. The variability of these two is about the same. Okay. So it's just showing that your test size should not be too small. Now, on the other hand, you need to consider that if your test size is larger, then you have less data for training. So a large test size like 0.5 can cause problems in your training. So this is showing you that test size is 0.3 is a good value in this case. And this is a very common practice to have test size around 20 or 30%. Okay, so that's what we can conclude from this exercise. Let's see if we can do one more exercise. Cross-validation. Okay. Right. Now, in this case, it's telling you cross-validation. Here it says that if you do one single split, you may get a value that is not reliable. We've already seen that there's some variation in the value. So this is saying instead of having one single split, you divide your test set into 5 parts and do 20% testing, 80% training, but you choose a different 20% each time. And this is going to tell me something about the variability of my result. Now, I would like to say that after I wrote this notebook, I did further research. And this is not a good practice. Although people do this, this is not a good practice. It's not a good practice. It gives a biased estimate of the uncertainty. Okay? It's give an estimate of the uncertainty, but it's a biased estimate. So this is not a good practice. We can run the exercise just so that you can have more practice in doing things. But I will show you in the remaining of this notebook how cross-validation is used correctly. But the principle is, once you set your test set aside, you don't do anything with it until the end. All right? So again, I'll say again that it's not a good practice to choose different test sets from the same data. It's better to keep your test set separate, do everything on your training, and the test set is only at the very end. Okay, so this is the correct way to avoid data leakage. And this procedure, which you will see in the literature, can give you an uncertainty, but it's a biased uncertainty. Okay. All right, so let me run this and see what I get. What this is telling me is I get so here I'm taking five-fold cross-validation. That means I'm taking 5 different test sets, and I'm using this AUC ROC. This is my evaluation. I'm not using accuracy, I'm using this other measure of the goodness of my model. And we'll talk about this also next time. Okay. So here you can see that each time I do this training testing split, I'm getting 5 different values. I'm getting variability. Here I have 0.804 plus or minus 0.047 for logistic regression. For random forest, I'm getting 0.760 plus or minus 0.55. Right. So this seems to indicate that logistic regression is better than random forest. But it's not a definitive determination. And the reason is because the error bars overlap. Right? The lowest value here is 0.804 minus 0.047, which is something like 0.76. And the highest value here is 0.76 plus 0.055, which is something like 0.814. Since the error bars overlap, you really cannot tell definitively which one is better. Okay. But if you have to make a choice, you choose logistic regression. Okay, so let me stop here. Again, I do encourage you to do this exercise at home. If you do exercises yourself, then we can go more quickly. I think that what we'll do on Monday, I will do this notebook once more, but even if we don't finish, I will leave you to do the rest. So I encourage you to read this notebook over the weekend. Do what you can do. Try to do everything, and then we can talk about it on Monday. Okay, so I would like to make some more rapid progress. As you know, I prepared something like 11 notebooks, and we've only done 2. So it would be good to try to make more rapid progress. Okay, I think we're finished. Thank you very much.
All right, thank you, Professor Trump, for that session. So